In this video, I'll be explaining what internal energy is. So, internal energy. And it is usually represented with the letter U, capital U. And well, the internal energy of a system represents its total energy. So, internal energy is another word for total energy. And what I mean by total energy is the kinetic energy potential energy and the molecular energy. You probably know what kinetic energy and potential energy are, but molecular energy simply represents the energy of the molecules. So if you have a gas molecule, as I said in the previous video, it'll move by translation, rotation, and vibration. If you have a liquid, it'll rotate and vibrate, and if you have a solid, it'll only vibrate. But so the internal energy is just another word for the total energy of the system. Now, in thermochemistry, the internal energy change is the sum of heat and work. So, internal energy change. I will just write it as delta U. When something has delta, like next to it, to the left, it represents the difference in energy, or the change in energy. So the delta U, I said, is the sum of heat and work. And heat is represented with a Q, the heat of the system, and the work of the system. So just Q is heat, W is work. And before I get into the practice problems, I want to write some factors that you will need to obtain the proper internal energy change of a system. When you read in a problem that heat is absorbed, that usually means, not usually, that always means that the Q will be positive, or the heat will be positive, because the system is absorbing it. It's gaining heat. Well, when you read with that heat is exerted or given off by the system, so heat is given off or released, there are many words for it, the Q will be negative, because the system, we are studying the system, and the system is releasing the heat, so it's losing heat, making it negative. So keyword absorbed, given off, or is the same as released. And well, those two values represent the heat, so our Q. We also said that in our formula we had work. So for work, let's see what the factors are. If work is done on the system, the work will be positive. So work is done, W will be positive. Actually, I should write the whole thing. If the work is done on the system, W is positive. Let me fix this. W positive. Now, if the work is done by the system, the work will be negative. So the keywords here are on and by. If the work is done on the system will gain work, because well, it's the work is done by the surroundings on the system, so the system is not losing any energy at all. But if the work is done by the system has to apply a force or has to waste some energy, meaning that the work is going to be negative. Now keep those four statements in mind when you're trying to solve a problem that represents internal energy change, because you have to write the proper sign for work and heat in the problem if you want to obtain the right change in energy. Now let's do some practice problems. The first one says, when a sample of gas expands, it absorbs 25 joules of heat and does 243 joules of work. What is the change in internal energy for the gas? So, let's write our key factors. It's saying that it absorbs 25 joules of heat. So, this is our Q. And our system, which is the gas, does 243 joules of work. So system does 243 joules, and this is our work. And we just want to find the change in internal energy. So delta U. The first thing you want to do when solving a problem like this is to use those key factors I gave you before. So absorbs and done. We said when heat is absorbed, the heat is positive. So our heat value will be positive. Let's go back. So heat will be positive. And you can just write a positive here. And then the system is doing work. When the system work is done by the system, right here, the work is negative. So we say that our work value is negative, or just a minus here. And now we just have to write our equation. So delta U is equal to Q plus W, and we put our values. So the heat is positive, so you just write 25 joules, but the work is negative, so it's going to be minus 243 joules. And our change in internal energy will be minus 218 joules. So the trickiest part of this problem is just knowing or determining the sign of each of the values that were given to you. So knowing if the heat is positive or negative, or if the work is positive or negative. Well, if you're able to determine that, obtaining the change in internal energy should be pretty easy. Just be sure to keep in mind the factors I gave you.